Good morning to one and all. My name is Dr. Jagadish, Assistant Professor, Department of Mathematics, Government First Grade College, T. Dorsali and Kasangudi. This is the program for the BCA second semester Mathematics, Numerical and Statistical Methods for Bangalore University. Today's session number 9. The topic is Newton's-Raphson method. So Newton's-Raphson method, let x naught an approximate root of the equation f of x equals 0. So f of x equal to 0 means we get the root, but x naught is the approximate root of, in this equation f of x is equal to 0. If x1 is equal to x naught plus h, be the exact root of the equations, where h is very small means 0.00 or it may be a fraction, then by Taylor series, we can write f of x naught plus h is equal to, we can write f of x naught plus h into f dash of x naught plus h square by 2 factorial into f double dash of x naught, so plus and so on equal to 0. That is f of x naught plus h. So we can express the series of f of x naught plus h into f dash of x naught by 1 factorial, but here is I'm not writing because 1 factorial is 1, plus h square by 2 factorial into f double dash of x naught plus and so on, which is equal to 0. F dash of x naught means the first derivative at the point x naught. F double dash x naught means second derivative at the point x naught equal to 0. Since h is very small, neglect the terms h square, h cube and so on. Okay. So h is very small. So therefore, after that higher powers, that is h square, h cube and h power 4, so we can neglect, means up to first two term, after that so remaining term will become 0. Then this equation will, we can write f of x naught plus h into f dash of x naught equal to 0. So from that I can find out h value. Therefore h is equal to, shift to right side and cross multiply, minus f of x naught by f dash of x naught. Substitute this. So in x1, so we have that x1 is equal to x naught plus h. Substitute h value. Therefore x1 is equal to x naught minus, so h value is minus f of x naught by f dash of x naught, provided this denominator not equal to 0, that is f dash of x naught equal to 0. If it is 0 means indeterminate, we cannot find. There's the conditions f dash of x naught equal to 0. Similarly, I can write x2 is equal to x1 minus f of x1 by f dash of x1, provided f dash of x1 equal to x naught equal to 0. In generally, I can write xn plus 1 is equal to xn minus f of xn by f dash of xn, provided f dash of xn not equal to 0. This is a general equation for Newton-Raphson method, also called Newton's iterative method. See, this is known as Newton's-Raphson method or Newton's iterative formula, that is xn plus 1 is equal to xn minus f of xn by f dash of xn, the provided this f dash of xn not equal to 0. In note, modulus of f of a is more than modulus of f of b, then the initial value approximation x naught is equal to b. Sometimes either, so you take a or b, we get the approximation value. Anyway, the root is in between a and b. So now we can solve the problems on Newton's-Raphson method. So that is only for algebraic equations. The first example, find the positive root of x power 4 minus x is equal to 10, correct to the 3 decimal places using Newton's-Raphson method. So in solution, I taken as f of x is x power 4 minus x minus 10. So I called as an equation number 1. So we can find the root between the equations. Therefore, so f of 1, replace x by 1, 1 power 4 minus 1 minus 10. So which is equal to minus 10, negative less than 0. Then you find f of 2. So replace x by 2, 2 power 4 minus 2 minus 10. 2 power 4 is 16 minus 12 is equal to 4 greater than 0. Therefore, the root lies between 1 and 2. So already we told that. So we take the consecutive, so values of positive and negative, that is the root. So therefore root lies between 1 and 2. Therefore, so I'll take the x naught is equal to, either you can take 1 also, we can find the, so that is the root, positive root between 1 and 2. Okay. So therefore the root lies between 1 and 2. Here is x naught is equal to, so 2. Now I can differentiate equation number 1 with respect to x. Then x power 4 become 4 into x cube, minus x become minus 1, minus 10 is a constant, derivative of constant is 0. Therefore, f dash of x is equal to 4 into x cube minus 1. The Newton's-Absent formula is xn plus 1 is equal to xn minus f of xn by f dash of xn. The first approximation n equals 0. N equals 0 means, so that is x naught is equal to, so we get x naught is equal to, what is that, 2. Therefore, x1 is equal to x naught minus f of x naught by f dash of x naught, which is equal to, my x naught is 2 minus f of 2 is equal to, already we calculated, 2 power 4 minus 2 minus 4 divided by f dash of x naught means f dash of x is 4x cube minus 1. In place of x, you can replace 2, 4 into 2 cube minus 1, that is 2. So minus 2 power 4 is 16 minus, sorry, 2 power 4 is 16. Already we are calculated, not it is a 4, it's a 10. So 2 power 4, f of 2 is 2 power 4 minus 2 minus 10, which is equal to 4 divided by, so 2 cube is 8, 8 4 is 32 minus 1 is 31. So after simplification, we get 1.871. Second approximation, n is equal to 1. Then you find f of x1. So f of 1.871, which is equal to x power 4 minus x minus 10. So x place is 1.871 all power 4 minus 1.871 minus 10, which is equal to 0.3835. F dash of x1 is, f dash of x1 is 1.871. So f dash of x is 4x cube minus 1. That is 4 into 1.871 whole cube minus 1. So after simplification, we get 25.199. Next, x2 is equal to the formula, Newton's-Absent formula. So for x2 is equal to x1 minus f of x1 by f dash of x1, which is equal to x1 is 1.871 minus f of x1 is 0.3835 divided by f dash of x1 is equal to 25.199. After simplification, 1.856. The third approximation, n equals to f of x2 is equal to f of 1.856 equal to x power 4 minus x minus 10. That is 1.856 whole power 4 minus 1.856 minus 10. So after simplification, we get 0.010. F dash of x2 is equal to f dash of 1.856. The 4x cube minus 1, that is 4 into 1.856 whole cube minus 1 equal to 24.574. Therefore, x3 is equal to x2 minus f of x2 by f dash of x2. Substitute x2 is 1.856 minus f of x2 is 0.010 by f dash of x2 is 24.574. After simplification, we get 1.856. You just compare x3 and x2. Both values are same. Therefore, x2 is equal to x3. The required solution is 1.856. The second example, using Newton's-Absent method to find a real root of x cube minus 3x plus 1 equals 0, we have to correct the 3 decimal places. The given function I call f of x is equal to x cube minus 3x plus 1 equals, 3x plus 1, I call equation number 1. Then you find f of 1, 1 cube minus 3 into 1 plus 1, that is 2 minus 3 is minus 1, negative less than 0. Then find f of 2, that is 2 cube minus 3 into 2 plus 1. So 2 cube is 8, 8 plus 1 is 9, 9 minus 6 is 3, 3 plus 3 is positive greater than 0. Therefore, the root lies between 1 and 2. I will take x naught is equal to 1. Newton's-Absent method formula is xn plus 1 is equal to xn minus f of xn by f dash of x1 xn. So now differentiate equation 1 with respect to x. F dash of x cube is 3x square minus 3x is 3 plus 1 is 0. Therefore, f dash of x equals 3x square minus 3. So I taken as the x naught, that is f of x naught means f of 1 is equal to 1 cube minus 3 into 1 plus 1 is minus 1. F dash of 1 is equal to 3 into 1 square minus 3. So which is equal to 0. That is denominator, I told that not equal to 0. Therefore, so Newton's cannot be applied by taking x naught equal to 1. Therefore, I can take x naught is equal to 1.5. Find out f of x naught equals f of 1.5. That is x cube minus 3x plus 1. That is 1.5 whole cube minus 3 into 1.5 plus 1. Simplification gives minus 0.125. F dash of x naught, which is equal to f dash of 1.5. 3 into x square minus 3, 3 into 1.5 whole square minus 3, which is equal to 3.75. Therefore, the first approximation n equals 0 is x1 is equal to x naught minus f of x naught by f dash of x naught. X naught is 1.5 minus, so f of x naught is minus 0.125 divided by 3.76, which is equal to 1.5 minus into minus plus the fraction 0.125 divided by 3.76, that gives 0.03333, which is equal to 1.53333. Second approximation, n is equal to 1. Therefore, f of x1 is equal to f of 1.5333, which is equal to x cube minus 3x plus 1. The x is 1.5333 whole cube minus 3 into 1.53333 plus 1 equals 0.0049. F dash of x1 equals, what is that? So that is 3 into x square minus 3. Therefore, f dash of 1.53333, which is equal to 3 into 1.5333 whole square minus 3. Simplification gives 4.053. Therefore, the formula is x2 is equal to x1 minus f of x1 by f dash of x1. x1 is 1.53333 minus f of x1 is 0.0049 by f dash of x1 is 4.053. So simplification gives 1.5321. The third approximation, n equals to, therefore find f of x2, that is f of 1.5321, x cube minus 3x plus 1, that is 1.5321 whole cube minus 3 into 1.5321 plus 1, so which is equal to 0. Therefore, I am not finding f dash of x2, but x3 is equal to, we can write x2 minus f of x2 by f dash of x2. x2 is 1.5321 minus f of x2 is 0. 0 by anything is 0. So simplification gives 1.5321. Compare x3 and x2. Both values are same. Therefore, x2 is equal to x3. Therefore, the required solution is 1.5321. The next example, using Newton's-Absent method to find cube root of 24 correct to the 3 decimal places. Therefore, I called x is equal to cube root of 24. So cubing on both sides, x cube is equal to 24. That implies x cube minus 24 equals 0. Let f of x equals x cube minus 24. I called equation number 1. Then replace x by 1. So that is 1 cube minus 24 is minus 23, negative less than 0. So replace x by 2. F of 2 is 2 cube minus 24 is minus 16, negative less than 0. F of 3 is 3 cube minus 24. So that is 27 minus 24 is 3 plus 3 greater than 0. Therefore, the root lies between 2 and 3. Therefore, my x naught is either you take 2 or 3. I am taken as here 3. Therefore, the formula for Newton's-Absent method is xn plus 1 equals xn minus f of xn by f dash of xn. Differentiate equation 1 with respect to x. Therefore, f dash of x equals 3 into x square. 24 is 0. Therefore, 3x square. Then you find f of x naught. F of x naught is 3. 3 cube minus 24. So that is equal to 3. F dash of x naught means f dash of 3. 3 into 3 square is 27. So first approximation n equals 0. So x1 is equal to x naught minus f of x naught by f dash of x naught. That is x naught is 3, f of x naught is 3 by 27. Simplification 2.8888. Second approximation n equals 1. That is we can calculate f of x1. F of x1 is, so f of 2.8888 equal to, the formula is f of x is x cube minus 24. That is 2.8888 cube whole power 3 minus 24 equals 0.10751. Then find f dash of x1 equal to f dash of x equals 3 into x square, that is f dash 2.8888 equal to 3 into 2.8888 whole square, which is equal to 25.0354. Then you find, so x2 is equal to, we can write the formula Newton's-Absent method. So for approximate n equals 1, x2 is equal to x1 minus f of x1 by f dash of x1. So equal to x1 is 2.8888 minus f of x1 is 0.10751 divided by f dash of x1 is, so 25.0354, which is equal to 2.8846. The third approximation n equals 2, then you find f of x2. So f of x2 means, what is that? F of 2.8846 equal to x cube minus 24 is 2.8846 whole cube minus 24 equals 0.00251. Then you find f dash of x2 equal to f dash of 2.8846, which is equal to 3 into x square formula. So that is 3 into 2.8846 whole square, which is equal to 24.9627. The Newton's-Absent formula for approximation n equals to is x3 equals x2 minus f of x2 by f dash of x2, which is equal to x2 is 2.8846 minus f of x2 is 0.00251 divided by f dash of x2 is 24.9627. So simplification gives 2.8845. So now you can compare x2 and x3, almost similar, 2.884, 2.8845 is there. Therefore, x2 and x3 are equal. Therefore, the required solution is 2.884. And next example is Find the real root of the equation x cube minus 10x minus 5 equals 0 in the interval 3, 4. Correct the 3 decimal places by Newton's-Raphson method. It's an exercise. And next exercise is find the real root of the equation x cube minus 2x minus 5 equal to 0. Correct the 3 decimal places by using Newton's-Raphson method. Next, using the Newton's-Raphson method to find the cube root of 37, the correct to the 3 decimal, just like we find it cube root of 24. Same method you can find out to get the answer. And these are the reference. So this completes this session. Thank you, one and all.